So if you're new to object-oriented programming, one of the new terms that you're going to run into is instantiation. Instantiation is a tough word, but it's really kind of simple. I want you to imagine that I want to build a house. Well, I want to build a house because my internet was so awful in Good, Virginia, I actually had to move to Lynchburg. True story. So I want to build this house. Let's say this is my dream home. We call this a blueprint. And the blueprint has the dimensions, the design, the plumbing, the electric, you get the idea. So if I ask you the question, is this blueprint my actual house? You would say, no. It's the plans for the house. It's the attributes, the design. So this will be basically my class. It's kind of my design, my layout. But when we instantiate an object, it's like saying, okay, I'm going to use these plans to build the actual house now. So that way, the home is built or is instantiated from the blueprints or from the class. So you build a really well-designed blueprint, if you would, what we call a class, and then we can instantiate objects. For example, a builder might want to build 5 of these homes throughout the neighborhood, maybe with different colors, a little bit different layout, so they won't be identical. But yeah, that class is still the blueprint for the objects in which he's building the other house. So now when I talk about instantiation and objects and classes, I hope you'll think back to this blueprint. So as the house, every house, the object, is a member of the big class, the blueprint of the houses. And a lot of times we say there's an is relationship. So the object is a concrete example of a class. So like the house is an example of the blueprint that I was going to build for the class. Or a zoo's shark is a fish, right? So this would be the object, and the big class is all the fish. So a shark would then be considered an instantiation of the fish class. We can reuse it. For example, we can build several houses, and let's face it, there are a lot of different kinds of fish, not just a shark. So now that we kind of have this, we're going to assign a name to the class. And then we're going to determine what data and methods will be part of that class. We're going to create a class header with 3 parts. This optional access modifier, remember the private, public type thing. So I was going to have the word class, lowercase, by the way. As you know, Java is case sensitive. And any legal identifier. Remember all the rules for an identifier. So let's kind of take a look at this. So far, we have built only what we had was the main class as a container. Now we want to build some more classes in here. So let's say now we have this public class called an employee, and we've never had this before, but we're going to assign a variable that's only going to be part of this class. It's going to be private, so it won't be able to use outside the class. It's going to be assigned to an integer, which is going to be their employee number, or emp_num. So we can have this class extended, so we can use it as a basis for any other class. For example, another builder might come into the neighborhood and say, hey, we really like the blueprint of the first house. Do you mind if we use this as a basis, but make a little bit of changes? Maybe we're going to do an extra window and 10 extra feet on the right side of the house and use it as an extended basis for this house. So let's kind of take a look at this in our next program, and then I'll explain some of these terms. So let's look at this code snippet. We're trying to build that house, remember? This is a class. There's always 3 elements that are part of that class header. The public is the access specifier, typically public or private. Always the reserved word or keyword class. And then here is the identifier. And don't forget, we always want an uppercase letter for a class. Now, just so you know, this particular class, there's no output expected. In fact, if I tried to run this code right now, it would fuss at me because I haven't really included the main. I'm just trying to show you how within this class, we can have all of these different methods or objects that are instantiating the class of the house. So inside this class, we're going to have two private data members. That means another class cannot know their value. They're private to this. It's just like whatever happens in your home is private, right? So no one else outside of your home would know about it, hopefully. So we have an integer called the number of bedrooms in your house. So for example, in my house, we have 3 bedrooms. And the double is the number of baths. And you're probably thinking, double? Why double? Well, for example, in my house, we have 3 and a half bath. So that could be a decimal. So that's why that's there. So now we are going to have, let's look through this. We have some get and set methods. Let me explain. We have right here, we're going to set that there are set the number of bedrooms. That's going to be this int number so something is getting passed into it. This is called a parameter, if you remember. And we're going to assign that number to num bedrooms. And because this is private within this class, now it knows throughout this code what these number of bedrooms are. Right here, we're going to get the number of bedrooms. So in this particular method object, we're going to get the number of bedrooms. It's nothing being passed in, so there's no parameter. But remember, if there is a data type here, this is called the return data type, and we're going to return the number of bedrooms. We can set the number of baths. How many baths? We're going to assign it to num baths, and we can return the number of baths. So in other words, we can break down all the elements of this house. Okay, we're now going to declare an object. Don't forget, object means it's kind of like build a house from the blueprints, and the blueprints are the class. Now, moments ago, we were looking at this piece of code down here. This is called the public class house. And this is, if we were to run it by itself, it really wouldn't run because it doesn't have the static void main string args, right? So we typed in this class. We're going to name that class house.java. In this class, we can reuse over and over again based on if we're going to build blueprints from this house. This tells how to build the house. This is our blueprints down here. Now we're going to build an object, or what we call an instance of the class. And to build this, to declare an object or the instance of the class, let's look at it. So we have this public class. This would really run. If I were to run this right now, I'd get bedrooms. There are 3 bedrooms in this particular house. Let's look through. You guys know the first all the way through line 4. Let's look at line 5 and 6 because that is going to blow your mind. So line 5 first starts out with the name of the class. Look down here. Here's the name of this class that we're about to reference. It's here and over here. What this right side says is I'm going to make a new instance of the house, the blueprint, and we're going to make an individual single house that you could move into. So that's going to be the new house that we build. And we're going to call that particular house, that one house that we build off these blueprints, my house. We call this the instance of this class, or we're instantiating. Another word is we're building an object for this class. An object is an instance of the class. So my house is called an instance or instantiation or an object, all the same thing. So after we basically declare that we're going to be coming down here and whatever we grab down here is going to be called my house, line 6 is now we're going to make a call to this class. We call line 6 the constructor. We're building the house, right? So let's look at it. we take this object, which is the instance of this class called my house. This is kind of like on the block. My house is called the Hoisington house. There we go, my house. We do something called object. That's my house. Remember the instance. We put a dot, and then we put the name of the method within the class that we want it to run. So let's say that slow. Object dot method name, not class. Object dot method. Every single time from here on out, every time you reference another class, you're going to put that object that you've declared dot whatever method you're going to. Now, the method that we're heading to in this constructor is we're going to pass down a value of 3. So we're telling it I need a 3-bedroom house. So we're going to pass it down here. This set number of bedrooms must be the same method name identifier as this method name down here. And by the way, this class house must be the same, class here and here. So we're telling it to come down, set it number of 3s. This is how we'll know when they go to build it that we want 3 bedrooms. Notice, because 3 is an integer, we are expecting an integer, so that's what we had to pass down. Try not to pass down a decimal and then assign it to an integer. You're going to get an error. And we're going to call that number. So the number 3 has been, the parameter name is 3. And we're going to say 3 is now the number of bedrooms. So now this house class down at the bottom knows they need 3 bedrooms. Now, let's go and see what happens. So this was setting this in memory. Now in the memory of the computer, num bedrooms is 3. But now let's do a printout. Systemout.println. This could be on the same line, but sometimes people break it up. They put bedrooms, space, plus, look at this. They're now going down to this class to grab at what they need to know. So we're going to go to my house. So let's look down here. My house, remember, is the object that we've declared. It's tied to house. And which method are we calling now? So we're now doing another constructor. Notice we're not passing anything down to the constructor. We're going to get number of bedrooms, but this one is returning a value. So get number of bedrooms returns num of bedrooms, and that, when it comes back to this, we don't need an equal sign and all. We can condense it. This right here, this call, this constructor that goes down here to get the information is going to print out just this number 3. You say, why go through all this mess? Well, don't forget, in a lot of programs, let's say we have at a bank, we have a class that does all the investments for a bank, all your bank accounts, savings accounts, everything. So we have these different classes that deal with this. Each person would log in. They would be an instance of logging into their bank account, but it would come down here and grab the information from your individual account and pass it back. They don't want every time you log in to get into everybody else's account. We just need your instance, and the next person logs in and they get their instance of what they owe or how much is in their account. So I hope this is starting to come together. So let's look at this particular piece of code. This would actually print, but it would need this secondary class that we would build for this. So this would be I want you to imagine that you're an employee, you work for, let's say you work for Food Lion. And at Food Lion, they have the clerks who check people out, and they have the drivers that deliver the Food Lion food to the store. Got it? So we're going to declare 2 employees. I want you to imagine that when you clock in, there's the old-fashioned clocking in system. You clock in with as you come into work that you've arrived. What this does is connects with a class that's maybe private, that's in Richmond, that does all the payroll for Food Lion all over Virginia. And we don't want anyone here in the local store to see the big database where everything else is stored. So this is why we have this. We're going to declare an object. We're just going to have an instance of these 2 employees that go clock in, so we remember what their employee number is. So we come in and there must be another method hiding from us right now. It must be called employee because there's, a class name employee, because we are now putting a new keyword to instantiate from the employee class an instance called clerk. So this is our object or instantiation of the class. So one of the types of employees is a clerk. And then we're going to call that same employee class again. We've got another type of role. We now have an object called a driver. So we have an instantiated class of the employee class, okay? So we're going to be calling this. So we're going to take that clerk. Remember, that's one instance of this object. We're going to call a method called setEmpNumber, and we're passing down this 345. It would need to accept some type of integer. It's not a decimal. So down here hiding from us is this method called setEmployeeNumber. EmpNumber, it's part of the employee class. And then we're going to set the other employee. So we have the driver dot set employee. So always think again, object dot method. So this is that object, that instantiation of the big class. And we're running a particular method, usually a set command. And I like using set here. It's going down there so it's saved. So we know this employee clocked into work today. Yay. And the big company Richmond now knows this clerk and this driver have arrived. And then it could print out. It says the clerk's number is, and we're going to call another method called get. Usually set means when you're assigning data. Get method is when you're grabbing information back. So there's another method in the class called getEmployeeNumber, and now we're going to go grab the clerk's information. So it's going to grab the 345, and it's going to grab the driver. And this is maybe needed for when we print the paychecks later that week at the Lynchburg Food Lion store. So hopefully you're starting to make a little sense of some of these pieces and parts that we're going. And we call this hiding the data, like what we're Richmond, the get and the set and that class is called encapsulation. That way we can keep information private. And we only need to have that access through public interfaces like a time clock or checking in through some app as you arrive at work. But we want to keep everything private in those classes. So we have the set method. It controls the data values that are used to set a variable, so it's being saved there. And usually we call it a get method when we're retrieving the information, maybe to print out paychecks later on. And we can see this a lot. We must have now a chauffeur. Food Lion has chauffeurs. I doubt that, but let's just go with it. So we have this object, we're making an instance of a type of employee. And so now we're actually calling a method named employee here. And this is going to be the instance of what a chauffeur does. So this is how we're starting to put things together. So please, please, please go back now and read the book, because I think you're going to need everything to start designing your code from this. And I think the sandbox is really going to help you build some of these pieces along the way. And by the way, the default constructors, if we provide specific initial values, let's say you just pass down a variable and it doesn't have a value yet, numbers are typically set to 0 if you don't have a value yet. Characters are set something to Unicode of 0. It just means no value. Boolean fields, if you haven't assigned a value yet, they're set to false. And non-primitive object fields are set to null. So in other words, if we haven't given a value like the 345 for the employee number, that's what they're going to pass down if you have given them no value. So get to work. Let me know how I can help. Dig in.